Hi, my name is Benjamin Coe. I'm going to be giving a talk today about some open source software that my team wrote to help us better release our libraries early, release our libraries often, but has also helped us make sure that this isn't our full-time job. As I said, my name is Ben. You can find me on GitHub at github.com/bcoe. I love open source software and contribute mainly to the JavaScript community. I have made quite a few contributions to Node.js, where I'm part of the tooling working group. We do a lot of work around the file systems, so things like recursive copy and recursive remove. I've also made contributions to Chromium, the web browser, and personally work on the libraries Yargs, which is an argument parser, and C8, which is used for test coverage. I was the third engineer at a company called NPM Incorporated, which is the company that for years supported the NPM JavaScript registry. This is where I really got interested in the releases and in releasing artifacts, and also in open source software, really. I today work on a team at Google that releases client libraries for over 100 Google Cloud Platform APIs. And these are, by this I mean APIs like Cloud Storage, our ML APIs, Secret Manager. So these are client libraries so you can build products yourself on top of these APIs. So I'm going to be talking today about releasing software using an open source tool called Release Please. So to give you a little bit of an idea of what the agenda will look like, I'm going to talk first about client library releases in general, a bit of a primer. I'm going to talk about the problem my own team was facing around releasing our client libraries. I'm going to talk about how we brought structure to a little bit of the chaos our team was facing. And finally, I'm going to introduce the tool we built to help with this process, Release Please, and kind of summarize the talk. So for starters, what are client library releases, and primarily how do they differ from other types of releases? For instance, releasing a web service or releasing your website. So when I talk about client library releases, I'm mainly talking about the idea of taking an artifact, it's usually a tarball, and putting it up to some registry, such as Maven Central for Java or NPM for JavaScript, Ruby Gems for Ruby, Composer for PHP, NuGet, PyPy, etc. For some languages, this might also just be the act of tagging an artifact on GitHub. I know Go used to work like this. And basically what this means is it's taking something like a GitHub repository where your team works on code, and it's turning it into a point-in-time artifact that's released to a customer. And what's kind of interesting about client library releases is your customer often then has their own users. It might be their own end users. So it might be that someone's using you as a dependency to build a website, which is then used by a large set of customers. So I have a quote here from Isaac Schluter, who's the person who wrote the NPM library originally for the NPM registry. And it's a good framing for how library releases are a little bit different than other types of releases like a website or web service. And to quote him, "An OSS library that has not had a single update in several years might be more well supported than one that gets an update frequently. Code that is simple and widely used by active maintainers has a potential to reach a done state very quickly." I think this is a good framing for one of the major things that's different about client library releases. Let me go into some more details about this. So here are some ways that I think client library releases differ from, say, a web service or a website. As Isaac points out, they do have this potential for reaching a finished state. Updates to a mature library may approach zero over time. In general, though, release frequency may be less than other types of products like a web service. Your customers are much more active versus passive. So whereas a website, a new stylistic change might go out and it doesn't have a huge effect on the end users other than maybe they find a button more easily. If you release a version of your client library, it's good practice for your consumers to in turn make sure they're up to date on the newest version of the library. And in turn, these updates to your library can create work for your consumers. Too many updates, especially breaking changes, can lead to frustration and fatigue. Client library authors saying, "Why the heck is there another release of Yargs this week? I just updated a week ago." This is the kind of mentality you want to avoid when you're releasing client libraries. Furthermore, because consumers are having to update their libraries in result to your updates, consumers need actionable information about an update, i.e. a good changelog. What changed in Yargs this week that makes me need to be able to take this update? Uh, as I alluded to earlier, your customers' customers are your customers. This makes libraries fairly susceptible to a type of security attack called a supply chain attack, where someone can target your library in an effort to target the end user of that library. So say that you are releasing a library that's in turn used by someone to build a site that's delivered to a Fortune 500 customer. It's important that your library follow good practices such as automated releases, providing detailed release information, such that there's actionable information for the upstream consumer to make sure that this is an actual update to your library and not perhaps a malicious update to your library in some sort of supply chain attack. So in this way, I think client libraries differ from releasing a web service. So to summarize a bit, client libraries might not be released as often as some products like websites, which might actually release several incremental changes a day. It's actually fairly often that a web service might deploy 4 times a day as each patch goes into it. However, even though client libraries aren't released perhaps as often, each release is potentially more time consuming. Consumers need actionable information about why they're required to upgrade their dependency for security reasons and just for quality of life reasons, making sure they don't break their own software. So having talked about the problem of client libraries and releasing client libraries in the general sense, I want to talk a little bit about the actual problem that my team at Google was facing. We have to release a lot of client libraries. My team supports 7 languages: Node.js, Go, Python, .NET, PHP, Ruby, and Java. And each of these languages has their own client libraries they have to release. The client libraries we're releasing are in support of 100 GCP products. These include products such as Cloud Storage, Compute Engine, Secret Manager, PubSub. All this said, over the last couple of years, my team has grown from having to release client library updates maybe a dozen times a month, or 50 times a month at most, to having to release approximately 1,000 updates a month. So before we started building this automation tool that I'm going to talk about a little bit today, creating releases for a client library was a very manual process. It took a minimum of 15 minutes per release. If you look at today, where we're doing 1,000 releases a month, this added up to about 6 full-time engineers would need to be doing client library releases each month to just get our releases out the door. But this is the only problem. Humans are fallible. We missed documenting important changes, released features as patches, missed breaking changes. In general, the process was breaking down a little bit. We knew that we needed to automate this. Here's the problem. This was about the quality of pull requests we had from our upstream API builders a couple years ago, because we had no real standardization. So we'd get this change in, which would have an update to our client library. The only context we had was that there was an update and it was to a specific API, in this case, phishing protection. We needed a better way to know what change had come from the upstream API producer. So in effect, we needed to find a way to bring a structure to this kind of chaotic information we were getting. So what we needed was a common language that folks rating these upstream APIs and folks releasing the libraries could use to make sure that we provided contextual information to our library consumers so that they could actually build things on top of our libraries. As I said, we had no way of understanding the nature of the upstream changes, and we had to put a detective hat on each time to we just had to look at code and see what had changed in the code, and then use this to try to describe what the change might actually be. We weren't good at identifying when a change was breaking. We didn't know what exactly it fixed. We didn't know if it was an exciting new feature we should introduce to our customers and kind of call out for our customers. So we had an idea for how we would start to bring structure to this chaos. There's this convention called conventional commits, which you can find at conventionalcommits.org, which describes a language one can bring to the commit messages they're writing to provide the context we were looking for from the API producers down to building these client libraries. So we started looking at conventional commits. Ultimately, we really identified that there were 3 main things that we wanted to draw attention to for our customers. We wanted to tell people when a fix was happening, and this indicates that a bug has been addressed in the library. We wanted to indicate to users when a feature had been added. Conventional commits allows you to do this with the prefix feat. And we wanted to more accurately indicate when breaking changes were coming through for our customers. So this was what the pound symbol indicates. It says that this change is breaking and should be a major update to the library. Conventionalcommits.org describes a variety of other small nuances to how someone should write conventional commit messages. But these were the three that we felt were most important for the problem we were trying to solve. And these were the three we evangelized to people working on these libraries. So if we take a look at the screenshot on the right here, you can see what commits look like to our code base as we started to adopt these conventional commits. The important thing that might jump out here is the fix, which says we fixed a bug down there towards the bottom. And the feature we introduced towards the top, feature in Secret Manager users can now use filter to customize ... So it wasn't too hard to start to convince people that this was better than the noise that we had in the prior example. There's another really lovely thing about these conventional commit messages, though, which is that they correspond very closely to this concept of semantic versioning. Semantic versioning is the idea that if you have a version number for your software, so 1.0.1, the least significant digit is updated when you're creating a patch release. The middle digit is updated when a new feature is added, and the most significant digit, the one on the farthest left, is updated when a breaking change is created. So what's really nice about semantic conventional commits is that it lines up very closely with semantic versioning. So let me show you what I mean by this. If we have a commit of the form fix foo, this is indicative of the fact that a patch is happening. So we update the digit farthest to the right. If we have the conventional commit feat, we know we have to update the middle digit. And finally, if we have an exclamation point on any type of commit, a feature or a fix, it's indicative of the fact that we now need to update the leftmost digit, and it's a major version of our library. So not only do we get more context about what's actually changed in a library by adopting these conventions, we actually have a better idea of what the next release of the library should be. So ultimately, to kind of jump to the chase a little bit, we've started to find that this language was working for us. Adopting a small amount of extra process allowed us to much better understand the software we were delivering. So this was great. And we did start to see adoption upstream. API teams were able to adopt this convention, and there wasn't too much complaining. For the most part, people understood that this would benefit the customers. But wait, there's more. The nice thing about this was we now had a structure that a machine could also learn, and we were in a position that we could actually start to automate our release process. So what I'd like to introduce to you now is the tool we wrote called Release Please, which is what we've been using to automate our client library releases based on these standard commit messages. So what is Release Please exactly? It's an open source tool that can be found at github.com/googleapi/releaseplease. And essentially, it parses conventional commit messages and proposes release PRs. You can see it on the right here, kind of going through the process of analyzing the commit history and opening something we call a release PR. What is a release PR? It's a PR that's kept up to date with the changes that would be included in the next release of your library. So if we take a look on the right here, we don't release a new version of the library with each new update that happens. We keep this release PR up to date, and it might include an entire collection of things that are going out to the customer. So in this example, we have a feature that's going out to the customer, and then we have a few bug fixes that are also going to go out to the customer. The other nice thing it does is it proposes what the next version bump will be for your library based on Semver, taking into account the fixes, features, and breaking changes. So in this case, we have 5 bug fixes that have happened and a single feature. The most significant thing takes precedence, so we're going to update it from version 17.0.0 to 17.1.0 in this specific example. Some other nice things that Release Please does for you is it maintains a human readable changelog, and it also updates all the language-specific files that reference the version number, such as setup.py, package.json, composer.json, cargo.toml. And here's an example of that happening in the right hand here. We can see that it's updating not just a changelog at the top, but it's also updating the package.json to be what this new version would be if we were to release this. So why did we go with this approach of a release PR versus, as I was saying, a web service might just release everything that lands on the main branch throughout the day? Well, it allows us to control the next release that goes out with more granularity. Perhaps it makes sense to release several changes in conjunction. Like there's a feature that relies on actually 3 components to land. So rather than kind of having to land each thing all at once, rather than having to land each thing individually, you might want to collect them up in a release PR and then land that release PR all at once. Another reason for my team is we generally try to avoid releasing things on Fridays. So by having this idea of release PRs, if you happen to land a bunch of work on Friday, we can just keep that release PR open and then release the software on Monday when we're ready for it to go out. Another advantage is it reduces this concept of update fatigue, where you don't necessarily want to give your customer hundreds of new library versions each week. It might be nice for them to get one version each week. In general, it just allows for more coordination. Major releases can be treated differently than minor releases, as an example. So what are some of the features of Release Please? Well, it supports many programming languages such as Python, Rust, Node.js, PHP, OCaml, Ruby, Helm. I don't even think I've named all of them. So regardless of your language of choice, Release Please actually supports it in many cases. It supports monorepos. So if you happen to be releasing many libraries from one repository, Release Please has fairly good support for this. It maintains a lovely human-readable changelog for you, handles bumping version numbers based on Semver, as we discussed. It creates the corresponding release on GitHub. So this is just the idea that you create a tag on GitHub and it has something similar to your changelog attached to it. Perhaps most importantly, it's open source. Many of these languages, such as OCaml, were actually contributed to us by external contributors. One thing Release Please does not do is it does not actually publish to the package registry like Maven or PyPy or NPM. We decided this, how this works differs significantly on a language by language basis. And we decided that we would leave that to the next step, which people can rate independently. So we decided this wasn't our responsibility. And just going back, I just wanted to give a brief example of what the lovely changelog looks like. So it's a nice markdown file. It includes links to the actual issue that was closed. It will contain links also to the users who contributed changes if you happen to reference them. So something that a person consuming your library can actually come and use to determine what steps they need to take to upgrade to the next version of your library. So a little bit of an epilogue. Has Release Please actually benefited our release process? Yes, it has. We've grown from about 20 libraries when I started on my team to releasing for about 100 libraries at this time. In that process, our releases have grown from perhaps a dozen a month to greater than 1,000. I think if we didn't have this automation in place, people would have grown very fatigued of the amount of time they were spending handling releases. And furthermore, as I said, I think just in terms of people hours, it would have taken at least 6 people a month to do it. So one of the other things that I thought was really great about Release Please was we showed that we were able to entice teams to adopt some simple conventions if we could show that it was beneficial enough to them. So why were people willing to adopt these commit conventions, even though it can be a little pedantic? Because it gave them fully automated releases with changelogs and semantic versioning. And also it's compelling that we're saving thousands of people hours each month. So in conclusion, you can try it out today. We already have lots of folks outside of Google using this software. You can find it on github.com/GoogleAPI/releaseplease. Thank you. And it was a pleasure to be able to present this to you today.